Okay, today we're going to go over solving quadratic by the quadratic formulas. Last few sections, we cover 3 other ways of solving quadratic equations. The first one was using factoring method. Second was square root property. The third was completing the square method. So the last one, because there are 4 ways of solving quadratic equations. The last one is using quadratic formulas. So if you wanted to use the quadratic formulas, then you need to remember the quadratic formulas. This is quadratic formula right here. In order to use the quadratic formulas, make sure given quadratic equation is the standard form equals to 0. So you have to have everything in one side equals to 0, where the one side should be descending order. From that, your A is leading coefficients, B is second coefficients, C is constant. And using that information, plug in this formula. Your formula will be negative B plus minus square root of B squared minus 4AC all over 2A. If you replace it in the formula, you should be able to figure out what X is going to be. So let's use the example. A. So this is standard form equals to 0. So from here, we know that A is 6, B is negative 5, C is negative 4. We need number with signs and plug in into quadratic formulas. So negative B plus minus square root of B squared minus 4 times A times C over 2A. Once you replace your value into the formulas, you just need to simplify them. If you have 2 negative, it will be positive. Plus minus square root of negative 5 squared is 25. Because you have 2 negative, right? Subtracting one of the negative. And when you multiply, that's what you're going to have. That will give you plus signs. And when you multiply 4 times 6 times 4, you're going to get 96 over 2 times 6, 12. Then you get 5 plus minus square root of 25 plus 96, 121 over 12. And we know that square root of 121 is 11. Once you no longer have square roots, then you should be able to combine them together, right? So when 11 is positive, you get 16 over 12. When 11 is negative, you get negative 6 over 12. When you simplify your solution, 16 over 12, 4 goes into 16 4 times, 4 goes into 12 3 times. Negative 6 over 12 will become negative 1/2. Let's look at the next one. The next one, the same thing. Only thing different, the given problem, it's not a standard form equals to 0. So that's the first thing you wanted to do before you get your ABC out from the given equations. So put it all one side equals to 0. And then from there, we know your A is 4, B is negative 8, and C is positive 1. Put it into your formula, you get negative 8 plus minus square root of B squared plus 4AC over 2A, which when you simplify, you get 8 plus minus square root of negative 8 squared will be 64, and then this is going to be positive, and 4 times 4 is 16 all over 2A. Your A was 4, right? So this is 4. So then this is going to be 8. When you simplify your square roots, 64 plus 16. Oh, again, your formula was negative right there, right? So let's change that. Subtractions. 64 minus 16. So then you're doing 64 minus 16, you get 48 over 8. And we should be able to simplify square root of 48 into 4 square root of 3. And when you reduce the common factor, it will be 4 goes into 4 one time, 2 times, and 2. So you get 2 plus minus square root of 3 over 2. And if you have radical, you don't need to be, or you cannot able to add or subtract into the whole numbers, so you leave your solutions like that. Let's look at C. So we do exactly same thing with all these types of problem where if you decide to use the quadratic formulas, make a standard form first, equals to 0. And if you wanted to pull the value into the coefficients, we can pull 1/3 times P, right? And then subtract 1 over 6 equals to 0. And you can use A as 1, B as 1/3, and C as negative 1/6. But if you don't want it to deal with fractions in quadratic formulas, all you need to do is get rid of the fractions then. How do we get rid of 1/3 and 1/6? By multiplying by 6 on both sides of equation, so we're not changing the given problems. Then we get 6p squared plus 2p minus 1 equals to 0. And from this, we will say A is 6, B is 2, and C is negative 1. Place it into quadratic formula. You're going to get negative 2 plus minus square root of B squared minus 4AC over 2A. And then when you simplify that, you get negative 2 plus minus square root of, that's 4. And you again have negative, negative. So this is going to be plus. 4 times 6 is 24. 2 times 6, 12. And when you combine inside of square roots, you get 28 over 12. And 28, square root of 28. You should be able to simplify further with 4 times 7, which is 2 square root of 7. And when you reduce the comment, then you get -1 plus minus square root of 7 all over 6 as your solutions. And don't forget, on my math lab, they maybe will ask you to write it into two different solutions. So you can do -1, one with the negative, and one with the positive. Let's look at the next one. The next one, we have a parentheses, and we don't even know if this is quadratic or linear, cubic, we don't know yet. So as soon as you see the parenthesis, without double thinking, you wanted to make a standard form and simplify, right? So you will do the FOIL, open the parentheses. Then you get 9x squared, 9x times -1, 3 times x, 3 times -1. And look like this is going to be quadratic, so I will put it all one side equals to 0 and combine the like term. Then I get -6x and plus 5 equals 0. So once you made a standard form, now you can decide which method you wanted to use, but we are on the section of solving by quadratic formulas. So if we wanted to solve by quadratic formula, get the A, B, C out, and then plug into the quadratic formulas. -b plus minus square root of b squared minus 4a and c over 2a. Once you replace your value into formulas, then you're going to simplify, right? So you get 6 plus minus square root of 36 minus 180 over 18. You might well say, well, how did you get 180 so fast? I did easy multiplication first because it's okay to change the order when it's a multiplications. So I did 4 times 5, which is 20 times 9. 2 times 9 is 18, and it was 20 instead of 2, so I add 0 to it. Then you get 6 plus minus square root of 36 minus 180, you get negative 144 over 18. And 144 is 12 times 12. So we know this is going to be 6 plus minus 12i over 18. And when you simplify this, you get 6 fit in everywhere, right? 6 goes into 12, 6 goes into 18. So it'll be 1 plus minus 2i over 3. Because you have an imaginary unit, you cannot add or subtract from whole number 1, so your solutions stay like that. Okay, next example, we're going to look at how many real solutions each of equation have. So in order to be able to solve this, we need to able to understand the quadratic formulas. If we're looking at the quadratic formula right here, the previous example we had 2 solutions. Why is it 2 solutions? Because you have plus minus sign in front of square roots right here, right? this plus minus signs. So if this number, if you end up getting the real numbers, the positive inside of square roots, then you're going to have plus minus here, so you're going to end up getting two parts of solutions like this one, right? Plus minus, one with the positive, one with the negative. So two solutions. That's what it say if b squared minus 4ac is greater than 0. So inside of square root is greater than 0, positive numbers, then you're going to get two solutions because you get to use plus minus sign in front of it, right? If this part inside of the square roots equals to 0, so if this is a 0, plus 0 minus 0 will be the same value. You don't have plus minus 0. That's just the same number. So it means you're going to have one solution. When this part is smaller than 0, you're going to get no real solutions. We had one of the example before. Let's see, the last problem, I believe, it had negative inside of the square roots. When it's negative, you get imaginary numbers. Imaginary number is not a real numbers. You do have solution, but it's not a real solutions. So that's why it say if inside of the square roots is negative, right, smaller than 0, then it will be no real solutions. Okay, so let's look at the A. 3x squared plus 4x minus 5. So if we change this into the standard form, we can tell your A is 3, B is negative 4, C 5 will move to other side, so C become negative 5, right? And when we replace it into B squared minus 4 times A times C, you end up getting 16 minus negative 60. So it'll be plus 60, which is going to be greater than 0. So you're going to have two real solutions. On that problem. Let's try another one. A will be 4, B is 1, C is positive 1. This is already standard form equals to 0. Just copy down. You don't need to move anything. Replace it into B squared minus 4AC. You get 1 squared. B squared minus 4AC. You get 1 minus 16, which is going to be negative 15, and this is smaller than 0. So what happens if it's smaller than 0? Value smaller than 0 means no real solutions. You will have imaginary solutions, but it's not going to be a real solutions. Let's look at the last one. A is 4, B is negative 12, C is positive 9. When you replace it, it will be negative 12 squared minus 4 times AC. So this gives you 144 minus 4 times 9 is another 144, which gives you 0. So because 0 is equals to 0, you have